video, we're going to look at the introduction to the concepts of correlation and regression. So I have a few notes here. We're going to be talking about bivariate data, or data in two variables, and we're going to reference X and Y. X is our independent data, so a little x-axis here, and Y is the dependent data. So a couple of things we want to talk about is, for correlation, is there a relationship between X and Y? And we'll have a couple different ways we can look at that. And if there is a correlation between X and Y, then can we find a linear regression equation in X and Y that we can use to predict values of Y for given values of X? So roughly speaking, we say that there is a linear correlation between X and Y if the correlation coefficient R is near -1 or 1. And the linear regression equation then may be used to make predictions. So a couple things that we'll talk about is we'll look at some graphs here. So I have some paired data. This is X, this is Y, and I'll say, all right, well, I plot this data. So these are the data values, and it looks like I could draw a line through that data set. And so in this case here, R is near 1. And again, R is the linear correlation coefficient. So you may be given the value of R in your problems, or you may be given the paired data, and then you can use technology to come up with the value of R. So in this case, R is near 1, and we have what looks like a line going through a linear equation, going through our data here. And in this case, the slope is positive. So if R is near 1, the slope of that line will be positive. We can have another situation. So X and Y, and we have some paired data and plot those data points. And in this case as well, it looks like they're pretty close together, but the line is going down. So here R is near -1. So if R is near -1, the slope is negative. And the last situation, or another situation we may have, X and Y, is the data points are all over the place. It doesn't appear that there's a line that goes through that data set, whether positive slope or negative slope. So in this case, R is near 0. And so if the linear correlation coefficient is near 0, then we say there is no linear correlation. And if there's not a linear correlation between the paired data, then we wouldn't apply the linear regression equation to predict values of Y for given values of X. We could come up with some other means for using a predictor, but we wouldn't use a linear regression equation. So one thing we want to do is we want to either find out or be given the value of R, and we can look at it and say, is it close to -1 or is it close to +1? And then there appears to be a linear correlation. And there's another approach we can go about as well. We can compare it to what we call a critical value. So if the absolute value of the linear correlation coefficient R is greater than a given critical value, and this critical value is based on the number of pairs of data or the sample size that we have for the given situation, the given problem. And you can look up the critical value in a table. So if the absolute value of that linear correlation coefficient is greater than the critical value, then we say that there is a linear correlation And then if there is a linear correlation, we can find out what that linear regression equation is and use it to predict values of y, again, for given values of x. So that's an introduction to the concepts of correlation and regression. And we'll also do a few examples involving correlation and regression.